Hi, today we will talk about ANOVA and regression. Our focus is on categorical independent variables. First, we will review one-way ANOVA. Second, we will talk about the general linear model. Third, we will introduce design matrix. Finally, we will compare ANOVA and regression, introducing dummy coding and effect coding, and what is the difference and the relations between these two important methods. Let's review one-way ANOVA. You learned this last semester with Dr. Nolan. So when we have different groups, we want to compare group means. When we have two groups, what statistical test we use to compare two group means? T-test. When we have more than two groups, we will use ANOVA to compare the mean difference across two or more groups. Here is an example about aspirin, Tylenol, and herb groups. These are tested to see how much pain relief each provides. Pain relief was rated on a 5-point scale. The independent variable is different drugs. It has 3 levels. The dependent variable is the level of pain relief. With this example, we want to know if there is any difference across aspirin, Tylenol, and herb groups. Also, we notice that within each group, such as aspirin group, there are individual differences. Within Tylenol group, there are individual differences. Same thing for the herb group. Therefore, in this example, we will have between group difference and the difference within each single groups. The rationale behind one-way ANOVA is straightforward. If the variance between groups is greater than the variance within the groups, then we will say aspirin, Tylenol, and herb have different pain-reducing effects. So here we want to test if the between group variance is greater than the within group variance. Do it. The first step of ANOVA is to form the research hypothesis. It is at least one of the means is different from the others. So the null hypothesis is mu1 equals to mu2 equals to mu3. Second, we need to set decision criteria. As a default, alpha is 0.05. Here we have the within group variance and the between group variance. So df between equals to number of group minus 1. Here we have 3 groups. df between is 2. df within total equals to df within for each group add together. So df within for the Tylenol group is n minus 1. It is 4 minus 1. df within for the aspirin group is 5 minus 1. df within for the herb group is 4 minus 1. Therefore, overall df within is 10. Now from the F table, the df between is 2. So we look at the top row, we find 2. Then df within is 10. We look at the left columns, we find 10. Therefore, F critical is 4.1. The third step is to compute F. F score equals to the between group variance divided by the within group variance. So the between group variance is indicated by sum of the squares for between divided by df for between. Then the within group variance is indicated as sum of the squares for within divided by df for within. So the top is mean square for between, the bottom is mean square for within. Now we have to compute sum of squares for within and mean square for within. We can use this table. Let's focus on each group. Let's focus on S' group first. The first is to compute the total score for S' group. It is 16, sigma y1. Then the mean score for S' group is 4. Then we square each individual scores. 3 squared is 9, 5 squared is 25, 3 squared is 9, and 5 squared is 25. Then we add this squared score together. We will have 68. Now we can compute the sum of the square within for the S' group. It is 68 minus 16 squared divided by 4. So it is 4. Next, we compute the sum of the squares for within for the Tylenol group. We follow the similar steps. So it is 56 minus 16 squared divided by 5. It is 4.8. Then we do SS within for the herb group. It is 18 minus 8 squared divided by 4. It is 2. Now we have SS within for the aspirin group, Tylenol group, and the herb group. So SS within total equals to 4 plus 4.8 plus 2, which is 10.8. What is MS within? MS within equals to 10.8 divided by 10, so it is 1.08. Next, we need to compute SS between and MS between. Notice we got the mean for the aspirin group, it is 4. The mean for the Tylenol group, it is 3.2. And the mean for the herb group, which is 2. These are called group means. Then if we take the average of these 3 group means, we will have ground mean. We use ground mean to compute the SS between. It is this formula. Let's focus on each group, it's easier that way. Let's look at the aspirin group. For this group, we use the sample size 4 multiply the group mean of 4 minus the ground mean and square the difference. Then move to Tylenol group. It is sample size of 5 multiply the group mean of 3.2 minus the ground mean of 3.07 a square. Similarly, for herb group, we have 4 multiply 2 minus 3.07 square. Then we add these 3 elements together. We will have 8.1. Mean square between is 8.1 divided by DF between. It is 4.05. At the first step, we will compute the ANOVA source table. It includes the between group sum of the squares DF, MS, and then SSDF mean MS for the within group. So it is 8.1, 2, 4.05. Then it is 10.08, 10, 1.08. Then the total SS is 18.9. Total DF is 12. F test equals to MS between divided by MS within, which is 3.75. Finally, we will compare the F observed score with the F critical score. F observed score is less than F critical score. Do we reject or fail to reject the no? What is the conclusion of this example? If you understand how to compute one-way ANOVA, now you take out the in-class exercise 8 and work on this in-class exercise. Be very careful about the calculations. After you finish this in-class exercise, you can start with the second section.